since it came up in office hours, I wanted to make a comment about manipulating tensors. So we have a set of rules, like, this is not okay, right? You can't have two upstairs indices, right? There's no two upstairs repeated indices. Free indices have to line up. And people ask, well, why can't we define a tensor this way? Like, why couldn't we just say my tensor, my vector v mu, is going to be t mu mu? Like, what's wrong with taking a tensor we had, t mu nu, and just looking at the upstairs mu mu component and calling that v mu? And the answer is you can do that in one Lorentz frame. But this equation will then not hold in other Lorentz frames. We set up this whole tensor framework with the idea that there'd be an abstract tensor that could be written as its components, denoted v upper mu, in any Lorentz frame, and those components would have a certain transformation law. So if I try to write down this equation, it's just nonsense until I tell you, oh no, this is only one specific Lorentz frame. You do this in different Lorentz frames, you define different tensors effectively. Okay, so that's why we don't do it. We want all of our equations to have a nice relationship to Lorentz frames. We don't want them to prefer special Lorentz frames. Right? The whole idea of relativity is that it's a good symmetry of nature. There's no fundamentally preferred Lorentz frame. So our notation should reflect that. And that's why we insist that you can't do this kind of thing. Okay? When we go to general relativity, it'll be the same thing, except instead of Lorentz frame, we're going to allow arbitrary coordinate transformations. We're going to insist that the laws of nature take the same form in any coordinate system.